Hey, welcome everybody to this fourth Bisq tech session. If this is the first one that you're joining, we've been doing this series now for a few weeks, couple months even, starting with a general technical overview of all things Bisq. Then we went on to talk about Bisq's peer-to-peer network. That's the second tech session. Then last week or a couple of weeks ago, we talked about Bisq's trading protocol, which is built on top of all of that. And today we're going to talk about Bisq's built-in Bitcoin wallet. So Bisq has a reasonably complete Bitcoin wallet within, and that's all based on BitcoinJ. All of Bisq's Bitcoin-related operations work with BitcoinJ, and we also talk to locally running Bitcoin core nodes if you have a locally running core node. And much more to say. I'm going to hand this over in just a moment to Manfred, who's going to present a deck on it. This should be fairly short today. We'll probably go 30 minutes or 45 minutes. If you have questions, ask them as you go along, and maybe keep them in mind, and we'll go through any questions we don't get to during the talk toward the end. I'll also write in the show notes below. I haven't done it yet. I'll put a link to the previous tech session so that everybody can see that. And we also just put together a contributor checklist on the new docs.bisq.network website yesterday. Maybe some people have already seen that, but that's a great way to kind of fast track your way onto getting everything you need up and running and ready to go if you wanted to start hacking around on Bisq, playing with it, and possibly contributing based on what you hear today. So with no further ado, I'm going to give it to Manfred to talk about Bisq's wallet and BitcoinJ. Here you go.
Yeah, hello, welcome everybody. I start my screen sharing, 1 second. Yeah. So yeah, as Chris said, we're talking about the Bisq wallet and BitcoinJ today. The agenda today, overview about BitcoinJ, some privacy issues in BitcoinJ and how we try to navigate around those. Since a year or so, we are using BIP44. And I give a little bit of background about this and the BSQ wallet. We are using an internal database structure connected with the wallet, so address entry database. We'll talk about this. There are some ideas and considerations to move away from BitcoinJ because mainly of these privacy issues, and can talk a little bit which alternatives are out there. And then about open task, what should be done in this area, and of course at the end time for questions. Yeah, I don't want to get into very details about what is SPV, what is HD wallet, and so on. If you're not familiar with this, there are plenty of resources out there to learn about this. Also, BitcoinJ is a SPV, a simple protocol verification wallet, so you're not downloading the full blockchain. And it is a HD, as a hierarchical deterministic wallet, which means you have basically one root key, and from this root key are derived all the other keys, which was introduced a few years ago in the Bitcoin space, and which is basically state of the art for all modern wallets. It's a sync. I'm not 100% sure if it's really the only Java implementation for Bitcoin, more or less feature complete. I mean, BitcoinJ could also run as a completely full node, but I think it was never designed for this. It was never really tested. So it's probably not very mature and feature complete in that area, but it's pretty mature as a SPV wallet. It's used in many implementations, like the Android Bitcoin wallet for mobile. Samurai wallet are using it, multi-bit. There are plenty of wallet providers which are based on BitcoinJ, and it's out since many years, so it's kind of like battle tested. Unfortunately, it's not very well up to date with the latest features for various reasons. Probably the main reason is just lack of resources, but I think other reasons are a little bit political differences to the camp, to that what Bitcoin Core is pushing and representing. I don't want to get into this, but for instance, replaced by fee, I think that's a feature which probably will not be added because there is not enough political support in the BitcoinJ camp. SegWit, I think, yeah, it's in work, and hopefully it will be complete soon. Yeah, there have been last year, there have been these attacks, several forks, and especially with B2X, it was quite a serious attack where if they would have succeeded, their SPV wallets like BitcoinJ could have moved over to another coin, to B2X, because it's blindly following the longest chain, which is pretty problematic, which would not be very difficult to fix. But it seems also there's no intention. So some people say, no, the longest chain is Bitcoin, even if it has broken their basic rules, like the limitation of their 1 megabyte block size. And that was, for instance, for us, the reason why we introduced our provided node, because when this would have happened, it would have been a mess. Suddenly your Bitcoin would have turned to B2X without notifying you and without your knowledge and so on. So it would have been really a disaster. And to a simple workaround, beside the technical fixes, which would have taken more effort, was that we were providing their Bitcoin nodes, the full nodes, and so the BitcoinJ is only connecting to those provided trusted nodes, and you are not getting on the wrong chain. I don't want to get into more details about this because that's kind of like a past story, and it seems that they failed with those attempts, and I hope they will not repeat it. But it showed that BitcoinJ is kind of like a weak element in our infrastructure, because when it would have happened, we would have had a lot of troubles and security risks and damage. I would like to talk very quickly about the Bloom filter issue.
Manfred, just before you move on, I don't think you plan to talk further about the provided nodes in any of the rest of your slides, right?
I'm not sure if I have. I have here.
I just want to mention a couple things real quick. One is that just in case that wasn't obvious what we're talking about today, when you spin up Bisq, by default, you're talking to, I think we have 10 or so Bitcoin core nodes that different contributors are operating. So we have our own federation, if you like, of Bitcoin core nodes, like Manfred was describing. And the reason that I just wanted to pause here and call this out is that this is one potential way that somebody could contribute to Bisq's overall Bitcoin support is being responsible for making sure that there's common configuration, that those nodes are tuned and always taking advantage of whatever the latest options are and so on, whether it's dealing with sort of a mempool size or what have you. We have competent people running all of those nodes, but there's no one person really on point right now to make sure that they're all operating in the best ways possible. So it's not all about coding, and it's not all about BitcoinJ, but it's also about we have that little federation of nodes out there that needs care and feeding, right? So just thought I'd point that out.
Great, thanks. After the next, when I explain a little bit the problems with the Bloom filter, it gets a little bit more clear why this provided node makes sense for us. I mean, and the problematics around it we'll describe also. Bloom filters are a probabilistic data structure. You can also read it up in the wiki. It's quite complicated, but in a nutshell, or in a non-technical description, which is not correct, but which represents more or less for how and why they are used in BitcoinJ, is to to have a more compressed. Also, I explained it how they are used. BitcoinJ sends a Bloom filter to a full node. It's usually connected to around 10 full nodes, random nodes in the Bitcoin network, and tell those nodes I'm interested in all transactions which the full node see in the network, which are relevant to my addresses in my wallet. When BitcoinJ would send all the addresses of its wallet to the full node, of course, you lose a lot of privacy. They didn't want to do this, so they introduced the Bloom filter beside of a more compact data structure. it provides a kind of like a privacy feature that you can add a false positive rate. So kind of like you're blurring your data, what you're sending to the full node. And technically it's not correct like I describe it, but it's a little bit like you are sending 100 real addresses additionally with 100 fake addresses. The full node doesn't know which one are the real and which one are the fake. So technically it's different because it's binary data with hashes and so on, but conceptually it's somehow like that. And that would give you some additional privacy if it really would be implemented correctly. And on the other side, I mean, it would not even give you real privacy if it would be implemented correctly, because it's conceptually problematic, because the full node with the transactions, what you get over time when you're receiving new transaction, he can construct a graph and he can figure out which are really your transactions, your addresses, and which are fake addresses. But much worse like this and easier to understand are a few terrible flaws in the Bloom filter. One is that this integer which is used, this random nonce, which is used for this random factor, is not persisted. So every startup of the wallet, you're creating a new one. So the random part will be always different. The real part will be always the same, a full node, which remembers the connection from your node, which especially for the other wallets much more problematic because they don't use Tor, so they know your IP address. They just can map it with your IP address. One day you send the Bloom filter with those 100 real addresses and 100 fake addresses. The next day you send again 100 real and other 100 fake. He make an AND of both and see which were the matching one, which are the same. Those are the real address, and all those which were not matching were the fake address. So it's very simple. And another main issue is that that they are sending not only the pub key hash, also the addresses, but also the pub key, which were used in the early days of Bitcoin. In the very early days, they were only a pay to pub key and not pay to pub key hash. And I'm not aware if there are still any applications which are using pay to pub key, because pay to pub key has security issues as well. And it's basically considered bad practice. And BitcoinJ is sending both to the full node, and the full node can, when he gets a transaction, he can derive from the pub key in the transaction, the pub key hash, can look up if in the Bloom filter is both the pub key and the pub key hash, then it's a real address. Otherwise, it's a fake. The fake is not really address, it's just other data which could randomly map to some transactions or to some addresses. But it's very unlikely that it would map to both the pub key and the pub key hash of another address. So that's another very efficient way to basically to clean up the intentionally added randomness and remove basically all the privacy features. So it's pretty bad, because you can assume that there are plenty of chain analysis nodes out which are collecting all kind of data for data analysis and selling it to governments and banks. And they are running full nodes. When you are connecting blindly to the peer-to-peer network, you are very likely get connected to one or two or more of those nodes. They are collecting your Bloom filter data, and at the end, they know more or less very exactly which addresses belong to your wallet. They don't, I mean, with other implementations, it's even worse because they know your IP address. With Bisq, we are behind Tor. When you use Tor, also in Bisq, it's optional. It's by default enabled that you go over Tor to the Bitcoin network, but you can disable it. So when you want, when you have very bad bandwidth or whatever, or when you don't care about this, then your IP address would be visible as well. But even without the IP address, as long as one address is identified with your identity, when you have used this address for buying Bitcoin on a centralized exchange, and they get this data, they can basically derive that all the other addresses belongs to this identified person. So it's really a serious privacy issue. I wrote a blog post about this a year ago. I have it at the end and the links in the references. You can read about more in details. And yeah, this Bloom filter problem is my main problem with BitcoinJ. I tried to fix it, but it was a little bit more complex and I didn't succeed at the end, and I didn't have time to step deeper into it. And our current solution for navigating around this as well, that was basically started with this attack last summer with B2X, that we are running provided nodes by trusted Bisq developers. Of course, we're introducing here a centralization issue in a way, because now you are trusting some developers, and it shouldn't be basically the case. You should be able to connect to a completely public network without privacy issues and security issues. But yeah, that's not the case, and that's probably the better alternative. It's optional, so the user can opt out. By default, it's on. So when the new user is downloading Bisq, he has enabled Tor and using only those provided Bitcoin nodes, because it would be enough when you have one time, the first time when you start up Bisq, when you would connect without Tor into the public network, and you are connected to one of those chain analysis nodes, you have lost already your privacy. And you cannot undo this afterwards. So it's important that we're starting with the highest privacy. When users, for whatever reason, want to go back, they can disable this and connect to the public network, or connect to the local host or to their own Bitcoin core node, which run on a server or whatever. That's for sure the best version, but most people don't do this for convenience reasons. And yeah, that's all the story around why we are running something like 10 or 12 nodes. All those people who are running those nodes are well known from the core developers and trusted, and so we can be sure that those nodes are not operated by a chain analysis company, and that you have reasonable privacy. Yeah, as I said, you can, when you have a local Bitcoin Core node running and you are starting up Bisq, then you are automatically connecting only to this local host node. So that gives you the best privacy, of course. And yeah, we are maintaining our own fork of BitcoinJ, and we added some privacy improvements. Like, for instance, we are not using the HTTP seeds, which are also bad for privacy, which were introduced and used by default in BitcoinJ. And we kicked out a few seed node providers like Jeff Garzik, his company has bought a chain analysis company. So I don't have much confidence in this guy, and especially he was the main guy behind B2X. And a few other stuff which are, which we would not like to follow the way how it's implemented in BitcoinJ. The most important extra implementation is the support for BIP44. A year ago, when I added it, it was not. It was just started as support in BitcoinJ, but it was not feature complete. I'm not sure how is the state today. That's an open task, and especially also to review my implementation, because that was done a little bit too fast and probably a little bit open risk if there are issues there, but so far we have not discovered anything. Is there something else to say about BitcoinJ? Yeah, with this fork, BitcoinJ, also our fork was based on the latest release, which is nearly a year out. And the current master, they didn't backport all the changes to the releases. So you basically cannot sync with the current master because there are tons of changes and it's completely out of sync. And we would like to get back to sync again with master, but that will be a bigger effort. And it would be then a proper process to make pull requests for our changes, to make it optionally or configurable what we have changed. In other words, for instance, to store this nonce for the Bloom filter to not recreate it all the time. It's very simple to just store an integer or a long value on disk, and at least reduce one of the many implementation flaws of for the Bloom filters. And yeah, next slide. Okay, I talked about the privacy stuff already. Yeah, and important thing is that the Bloom filters, even if by implementation they are fixed, they are broken conceptually. That you are sending the important information to a full node, and with chain analysis, of these transaction graphs, you would always lose privacy. So even if it would be perfectly implemented, it would be still bad for privacy. And it's basically in the Bitcoin core camp, and yeah, everybody regretted that was ever added to Bitcoin. And there is some work in progress with client-side Bloom filters. That means basically that for every block, a Bloom filter gets created. When you are starting up, you are collecting all the Bloom filters from the whole blockchain. That's quite a bit of data, but it's not super terrible bad. I think it's something like maybe a gigabyte or less. And then you are picking up, then you can make a check which blocks are interesting for you with your addresses locally. Then you don't need a false positive rate at all. You are just iterating all the Bloom filters, and you find out which blocks are interesting for you. In practice, it's easier because you're usually not interested in the past blocks, because your wallet, when it's created, you cannot use or you cannot have received any money on your address before you have created your wallet, because all addresses are new. So you basically only start from the wallet creation date. And in practice, I think it would be really a doable stuff, and you don't need to download a gigabyte. You maybe need to download 100 megabyte, but that's also with BitcoinJ, when you're not in sync, it can take quite a bit of time to download the required data, and it's quite slow. Yeah, these other implementation flaws which I tried to fix were, I think it's not very, when somebody's really familiar with BitcoinJ as the library, I think it would not be too hard to fix it. But at the end, of course, it will never be a perfect fix. So it's the question if we should really put effort in something which doesn't really help too much. It would help a little bit. I think it would it will make it a little bit harder, at least to find out which addresses belongs to one user, and maybe reduces the probability of the correctness. Yeah, BIP44, the basic idea with BIP44 is that there was added extra passes in the structure, in the tree structure of the derived keys. So yeah, with a HT wallet, you have a master key, a root key, and from them, I don't remember exactly how the passes are, but you have a kind of like a few layers of tree branches, and BIP44 added extra branches for defining, for instance, special color coins. Like, and there is a registration page where you can do this, where you can register your coin. We did this, as we have the number 142 for Bisq. And it helps just that you are separating this wallet from other implementation. And I explained a little bit why we use it for us with Bisq, because we wanted to have one root key for the whole wallet as one seed words. We didn't want that the user need to have maintained 2 seed words and 2 passwords and everything. But we still want to have 2 wallet files just for a little bit of extra security, that are when a file get corrupted or whatever, and backing up. And with this, we have basically the same root key, but then we have 2 branches. One branch is for the Bitcoin part, which has a register coin type as well. I think it's 1 or something. And then we have another branch for the 142 with for the Bisq wallet. And when a user would, for instance, use the seed words to recreate the wallet in another application, then he would not be able to access the Bisq address, and would not be able to spend and do any mistakes with the Bisq address. So the main motivation were that we avoid that users who are not well enough informed, they think, okay, it's a HT wallet, I just put in my seed words in another wallet, and then I can spend my Bisq, and they would have destroyed the Bisq, because when you are spending the Bisq tokens in an incorrect way, you are burning them, you are making them invalid, and that would have nearly for sure happened when a user would do this. And with this model, we have a built-in protection. It would be just not recognized. you would need to have another wallet which supports BIP44, and then you need to know this coin type and map it there. Then you could recreate it, but then you already know a lot about how it's done, and then you should know that you should not spend the addresses from another wallet where it's not implemented the way how BSQ tokens are working. Yeah, in Bisq we want to maintain the state of addresses which are used in the trade protocols. So when you are creating an offer, you're creating this this maker fee transaction, and the one output of the maker fee transaction is exactly the money, the Bitcoin amount, what you need for when somebody is taking your offer. Because when you would not reserve this, and in the meantime you would spend this funds, and somebody will take your offer, it will fail because you don't have the funds anymore. So it's important that we are kind of like protecting and reserving certain transaction outputs. It was unfortunately a mistake, a conceptual mistake, that I used addresses instead of transaction outputs here. I mean, it didn't have really big consequences, but I regret that I have done this that way. And and we are keeping track of those. We are basically attaching a context. A context can be like funding or funding trade, or reserved for offer, or later when it's in the multisig, or for the payout. All these addresses which are used in one trade get a certain context, get basically a metadata attached, and we are maintaining the state of this in a separate file. So it's just a protobuffer file which gets persisted to disk. And that's the second thing what I regret to have done it that way. I was not aware in this time that there is an extension mechanism in the wallet. So we could have added probably this metadata directly in the Bitcoin wallet. And that would avoid problems like, when the user has a crash and one of the two files, either the Bitcoin wallet or our internal database, was not stored, then you're out of sync and you have troubles. And there are sometimes problems in that area. So it would have been more safe to have only one file where it's atomically stored or not, and to have to reduce the attack surface or the problems, the risks for getting out of sync. As it was already audible for you, I'm not a super fan of BitcoinJ. I think it's for Java probably the only and the best solution, but with all the privacy issues and also a little bit this different political views, like for instance, they're not supporting, or I'm not aware if there are plans for supporting replace by fee, but I know in the past BitcoinJ was done by Mike Hearn, and Mike Hearn was very opposed to Peter Todd, who was the main driver behind replace by fee. And as we know now, with the problems with high fees, replace by fee is a super important feature for a working fee market that you can negotiate better on your side, basically. And what are the alternatives? And one alternative for me, the most interesting, would be to use Bitcoin Core in SPV mode. It's called hybrid full block SPV mode. That's a work introduced or started by Jonas Schnelli. I think it's not merged and it's not really complete. It's probably in a good state, so maybe we could use his fork and it would work sufficiently. But hopefully it will be completed really and merged into Bitcoin. And it's basically that he tries to optimize everything to make it possible to run Bitcoin Core as a light client in a way. So it combines pruning, it combines or it introduced new strategies of block download and a block header download. So you would start from as far as I remember, I'm not 100% sure if that's all correct what I say now. You would start from your wallet date, when your wallet gets created, to request all the block headers. That's the same like SPV, SPV wallet is doing. And then when you have the block headers, you can figure out if you have a transaction which is part of the Merkle tree. And then you are downloading all the transactions or all the blocks which you're interested in. and only after you have really downloaded everything what you have already, then you would go on with downloading the full blockchain in the background. I'm not sure if that would be mandatory or optional, because even if it would not affect usability anymore, because you don't need to wait for something, it would affect resource requirements for bandwidth and for disk space. So basically for Bisq, I would like to have it optional that a user don't need to download the full blockchain, even later when it's not so critical anymore. And I'm not 100% sure how they deal, or they don't have Bloom filters. I think they probably would deal with this client-side Bloom filter concept, but I'm not 100% sure, and it would need some more investigation to see if it's really feasible, if it really would be okay for our use case, that it doesn't require a lot of bandwidth and CPU resources and disk space. But I have high hopes in this, and hopefully this work will be usable someday. And then in Bisq, we would integrate it the way like we do it with Tor. We would just add the binary to we would ship the Bitcoin core binary, or the daemon, and we would communicate over RPC probably, or something else, with this binary, same like what we're doing with Tor. There we have a TCP channel, a control channel to communicate with Tor. And in that way, the user don't see anything, or he doesn't need to install Bitcoin Core or whatever. It just comes with the application, and for the user, basically, it's not the difference. Another option might be Neutrino, which is used for a Lightning application. I'm not familiar with it and doesn't know anything basically, but somebody mentioned it and seems that interesting. SPV implementation. There is a Scala implementation out. I post the GitHub link at the end of the slides. I have not looked to it, but it seems it's under active development, so might be interesting to check out one day. It's probably a high risk to move to another implementation which is not already really used, because there could be tons of bugs. It's super complex at the end. And my main favorite with using Bitcoin Core is also because we would have all the latest features and all the best privacy improvements what hopefully will come with upcoming versions. We get this all for free without any extra risk, and it's the best tested and most mature implementation, of course. So that would be by far my favorite candidate, if it holds the promise that it's usable for our needs. And if anybody knows some other alternatives, of course, would be open. Beside that, I mean, when we find out all those alternatives are not really usable for whatever reason, I would love that we find a dedicated developer who is either already expert in BitcoinJ, that would be the best because a big and complex library, or who is at least an expert in the Bitcoin space, so he really knows about and following all the development on Bitcoin. And help us to improve this stuff. In the best case, I mean, there is the Samurai wallets. They also work with their own fork. They have already implemented SegWit, and probably they have fixed some of the privacy issues as well. And I think also we are sharing a lot of common ideas and philosophy about privacy and about decentralization with the Samurai wallet guys. So it might be also interesting to join effort with them and try to improve all the weak areas. And theoretically also this Bloom filter problem could be solved. It's just a lot of effort. I mean, could be implemented to use this client-side Bloom filtering and change all this. It's just huge effort, and we, at the current state, of course, we don't have the resources. But when we find a dedicated developer who take over responsibility for that area, that would be great. And then we can work on improvements on this. And we have basically really pressure with SegWit. As soon as BitcoinJ has full SegWit support, we really should implement it also and add it to Bisq. And then, we need to move over to the latest master. We want to get our changes in, especially the BIP44 is the most critical part. Hopefully they have already implemented it also fully, so we don't need to do anything. But it might be that it's still not fully implemented, and then we have to port our changes there, and that will be a little bit a problematic process, and to get our changes merged into the main branch. So that's also quite a lot of effort. I will not really have time for this. So when any developer who is familiar with BitcoinJ and Bitcoin and Java is highly invited. So yeah, I talked already about this open task. The review of my BIP implementation is probably the highest priority, to check if there are some open issues which are not discovered yet. In parallel, or after this, check out the current status of the BIP44 and BitcoinJ. Maybe it's already feature complete, and so maybe not. Maybe some parts are implemented and done better, like I've done it, and could be changed. But I mean, it's a working wallet what we have out since 1 year, so it's a very dangerous area to touch. And yeah, to investigate these alternatives, what I talked about a minute ago, to bring our fork in sync with the master. I also talked about to make pull requests for our improvements, to check the SegWit status, and maybe as when the main branch in BitcoinJ takes too long with SegWit, a Samurai wallet has already support for SegWit. I'm not sure about the details and so on. There are a few important details, but some implementation not supporting all the versions and all the BIPs and all the with the native address formats and so on. So I'm not up to date with all these details. And of course, to add SegWit support for Bisq. I think when BitcoinJ would support SegWit, it's probably pretty trivial for Bisq to support it. Maybe no effort at all, or maybe a little bit, but I don't expect it's a huge effort. I kept out Lightning because that's a complete own story, and maybe in future we make our own tech session about ideas with Lightning. But the main problem, as far as I've followed it, I'm not very up to date with Lightning. But what I heard from the Open Bazaar guys, which are using a similar concept like we are using in the trade process with this multisig and security deposits, is that in Lightning Network you cannot at all use multisig, or it's a very different model or much more complicated. And that will basically break our security basics, how a trade works. So to support Lightning, many people are requesting this, and I would love it also to have Lightning support, but it's a big story, and I'm not sure if and how it will be possible, at least not short term. Yeah, here are some references to this blog post I done about this privacy. It's more broader about privacy in Bisq, but especially about the Bloom filter, because that's a major issue, or the only real big issue, which is kind of like, I think with this provided Bitcoin nodes, we have navigated around it. So I think it's not a burning problem anymore. We changed the problem, so we have a little bit more trust or centralization problem, which is, in my opinion, more a theoretical problem at the moment, like the very practical privacy problem. But anyway, yeah. Then, this page where you register the coin type for BIP44, the SPV mode of Bitcoin Core, and the Scala implementation. Here, are there any questions?
There haven't been any questions in the chat so far as I've seen. But anybody who's watching right now, if you want to type stuff into the chat window, we certainly can take a couple of minutes. And while we wait, just to see if anybody does show up with questions, I'll just kind of recap all of that. I think is actually a really big opportunity for somebody or some bodies to come along who are ideally already, pretty familiar with Bitcoin development, ideally BitcoinJ development, but also if you've just gotten your feet wet in that world, or you have a little bit of experience and you want to come help do basically the unglamorous work, right, of getting us in harmony with what's on the master of the canonical BitcoinJ fork, just all that kind of like low-level work and just incrementally begin to take care of and ultimately possibly become the maintainer of Bisq's Bitcoin integration, however it evolves, whether we stick with BitcoinJ, whether we really start to get serious about maintaining our own fork and making it really a first-class fork, doing the alternative options that Manfred talked about. I mean, this can ultimately be really juicy work, right? Like imagine the scenario where we start shipping Bitcoin Core and running it in SPV mode, like Manfred described, and we're talking to that over RPC. Obviously, that's all going to be happening via Java. Could be a nice lightweight little layer that we need to write there that could become its own library. I mean, there's all kinds of stuff that can be done, and we tend to be in this mode where we're thinking, highly prioritized and what the most important things are. We have these kind of major privacy issues, and of course those are the first things that need to get handled. But as people start to really show up, especially if we have basically 0 people dedicated to this right now, but if we have 1 or 2 or even a growing team around this, we could start to do really ambitious things. Who knows what we can do with Lightning? Who knows what emerges with all of that, right? So there's, I'd say, everything that Manfred had said was great. It's all perfectly true, but it's also worth kind of stepping back and thinking big and thinking long term. And that all starts with, of course, showing up and just submitting some very small fixes to right now problems. But yeah, keep all that in mind. Go ahead.
Actually, that would be a really interesting application or a library for supporting a Java wrapper for BitcoinJ, because I mean this model that you're shipping the binary and you're talking with the binary.
For BitcoinJ or for Bitcoin Core?
Bitcoin Core, sorry. Yeah, to ship Bitcoin Core in the binary to have a interface, either RPC or a 0MQ. I'm not sure if that would work for this needs. Or either implement some extra new binding and have a special version of BitcoinJ which has faster, because RPC is a little bit slow. But depends what you're doing. For normal wallet usage is probably good enough. And I think that could be really an exciting application where other projects which are based on Java could pick up and use. I mean, for Android, unfortunately, it probably will not work, or will not work for sure. But yeah, all normal desktop applications could use this and could get then the best of the best inside of the application and can still use it in a Java application without complicate bindings to other languages.
Exactly, and I think that between projects like you talked about, Samurai, which is great, and we've talked to one of their developers like relatively recently. He showed up in our Slack and we had a brief chat, and we basically said, look, we're essentially looking for the same person or persons to work on Bitcoin related stuff. Them, of course, for Samurai, and us for all things Bisq. And we began to talk about, like, well, maybe we could somehow, share that resource or whatever. I don't know how that would work. I think they have a more traditional employment model, but under the Bisq DAO, it's all task-oriented compensation. Which, by the way, I should mention, right? I think we'll really try to circulate this video a little bit more widely than we have these other tech sessions, because this is, I think we need to cast a bit of a wider net to catch all the people in JVM land who might want to do this kind of work. People should know that we're looking for this. So if you're watching this and you're not like really familiar with Bisq and what we do, keep in mind that everything we've talked about here, every valuable contribution anybody makes to Bisq is subject to, or eligible for at least, compensation under what we call the Bisq DAO. So you can read up all about this in the show notes. There's the contributor checklist, and in there you'll see a link to a document called Phase 0. And if you read there and search around for BSQ, you'll find how we compensate work under the Bisq DAO. So this isn't about just doing some side work. This is actually about getting compensated for good work. If you I just want, so there's a little bit of a digression, but the point is that somebody who's doing this level of work could potentially be doing that work for a couple of projects at least. Like there really might actually be something that we could do with the Samurai team. And I think it's just a huge opportunity for projects like Bisq and Samurai. It's a small number. They're the kind of the vanguard on the JVM. We can really basically begin to lead this and contribute a ton of value to the community, get the stuff that we need done, and start really like doing cool stuff and having fun with it, right? People just got to show up.
Another project is Mycelium, or I'm a little bit in contact with one of the guys there, and are using it as well, and we're sharing the same concerns about privacy and so on. So that I think it could be really a group of users of BitcoinJ which are not super happy with certain stuff in BitcoinJ, and when we find a way to focus resources and improve this stuff, might be, and especially I think for the Android developers or Android projects, also for this project which need a mobile version, there is probably no alternative out there. And this Scala implementation might be interesting, but it's a huge risk to change to a completely new version, even if it's great implemented, but you never know which future, but you're the beta tester, and people who have a running application out don't want to be this usually.
Yeah. Okay, last call for any questions. I don't see anything else coming up in the chat. Of course, you can always come talk to us afterward in Slack. Again, contributor checklist below. You'll see all the right links to come figure out how to say hi and introduce yourself and follow up. So yeah, thanks everybody for attending. I think we had 10 or 11 people watching as we went, and there's always these tech sessions always get I don't know, dozens of maybe a couple hundred views within the week. So to all those who weren't here live, hello, and yeah, come talk to us. Anything else from your side, Manfred?
No, I think we are fine. I mean, what could be the next topic for a session?
Good question. I have some ideas around some higher order stuff around participating within DAO and things like that. But from the purely technical side, what would make the most sense to you next? I mean, we can certainly do desktop, right? You know, how the UI layer works.
I think that's a good the UI and desktop. That's maybe for next week or so, and maybe Christoph can be there, the main, or beside me, maybe do it together. So I would like to make one also about the DAO implementation, but I want to wait until it's more complete, maybe in 2 or 3 weeks or 4 weeks.
Yeah.
But yeah, let's schedule for the desktop and UI.
Good. So we'll roughly plan to do another one of these around this time next week. We gotta get all our calendar and stuff like that. But until then,
okay.
Thanks and goodbye.
Thank you. Bye bye.